Hello, my name is Atlas Johnson and I go to Wake STEM Early College High School in Raleigh, North Carolina. Today, I will be talking about being an air traffic controller and how this relates to functions. So, when it comes down to it, we use functions in air maintenance and flight plans. So, air maintenance is just fixing and maintaining aircraft, and flight plan is just the plan that air traffic controllers come up with to get the passengers to their destination safely. In terms of flight plan, you're probably wondering, what does the flight plan have to do with functions? And that's a very good question, which I'm about to answer. So, in terms of trajectory, trajectory is just like the path of the travel, and you're going to want to use functions for this because you have to determine, as I said earlier, the maximum point and how long it's going to take you to get to the destination. And this is very important because you want to avoid all dangerous situations at all costs. And so what functions do for this is provide a great flight plan that will take you to where you need to go and get you there safely on a distinct plan. A reason why I would love to be an air traffic controller is because I love flights. Now that I've been on a few, I love them, and I just love being in the air, as I like climbing mountains such as Stone Mountain in Atlanta, Georgia, as you can see in this picture. And also I love being in command of people, such as like leading people to do things, and I like to get people to places they need to go safely. Now we will talk about airplane maintenance and how this relates to function. So now, as we go into the subject of aircraft maintenance, we talk about the functions. And so one of the functions for aircraft maintenance is basically just determining the total cost of a function. So basically just determining like how much a part costs, and so just the total cost is basically just a function of the output. So you might choose Q to represent the output, and then just write total cost as in TC as a single variable, and then the function can then be expressed as TC equals F times Q, and then Q is just representing the output. Now we're going to go back to the subject of flight plans, and so we're just going to be talking about three basic things on the graph. So we're going to be talking about the initial point, the maximum point, and the final point. So the initial point is just like where you're flying from in this case. So that's going to be like at 0, 0 on your graph. So we'll call the initial point RDU, which is Raleigh-Durham International Airport. And so along your journey, you're going to be plotting points to your maximum point. And so your maximum point is going to be somewhere along your journey. And so you're going to plot that. And then along your way to the final point, which is just the airport that you go to last, you're going to be plotting points. And then so your final point, we'll just call it JFK, which is John F. Kennedy International Airport. And so you're just going to be plotting points, and once you see all your points together and you put a line through them, you find that this function of the airplane will look a lot like the negative x squared parabola, with a maximum, initial, and final point. And yes, so what you can learn from this is that airplanes have the graph of negative x squared as a parabola sometimes, but they can also have different functions, so you just got to remember that. Thank you.